Thanks for having me this morning and giving me a chance to share some of the work we're doing. You'll have to forgive my sniffling. I got a little cold the last couple of days. And so essentially, as was said before, I'm at Genentech, and we have a relatively large late phase program. So late phase is after the drug's already on the market. Phase 4, we're mostly doing data mining and publications and things like that. So this example here, we have quite a large respiratory portfolio. And this is one of our asthma drugs. And we're looking for who responds best to this drug in various patient populations. So that can be done a number of ways. And the CART piece, the data mining piece, is sort of just one component of the overall project. I thought we'd focus on that since we are at a data mining conference. So we use CART quite a lot at Genentech. We have 3 licenses, three people focus on data mining a lot, and then one of our statistics vendors who helped me build these slides also does a lot of data mining for us. So what we're trying to do is you have a large database with hundreds of variables, and we're trying to figure out what patients get the greatest advantage to the drug for various reasons. One, physicians are often not comfortable treating with a biotech drug. They're really expensive and dangerous sometimes, and you want to find, it's often the treating physician wants to find that one golden patient to try out for the first time using the drug. So they're really pushing for responder analyses and interactions with therapy so that they can actually pick that one golden patient in their minds. So taking a database with hundreds of variables in it, it's often difficult to go through and test with a standard regression analysis, one variable at a time. You can imagine how tough that would be. And then there's interplay between variables. Maybe there are 2 or 3 that it's the left-handed patients from Germany or whatever it is, some kind of interaction that are actually getting the best benefit from the drug. And it's not just a one variable interaction. So one approach that we have to fix solving this problem is to take the database and shrink it down by doing cluster analyses. Instead of working with 100 variables, we work with 5 or 10 clusters. And then we move forward with testing interactions the traditional way. When you do clustering analyses, there are 2 standard, I don't know how familiar one is with clustering, but there are 2 standard approaches. In your database, you have rows, you have patients, and you have columns. So I know there's John, Susie, Sally, and there's their blood pressure and their age. So you can either cluster their variables, blood pressure and age go together, gender and region go together, so on and so forth, and shrink it that way. Or you can shrink the rows and just take similar patients and group them. So the first method is called variable clustering. Variable clustering creates a funny composite score. It's based on principal components. It's a little complicated. And patient clustering is what I'm going to focus on today because that's what's in most of the medical literature. There's a lot of cluster analysis in asthma in the medical literature. There's actually an entire group dedicated to doing clustering called the SARP group, S-A-R-P. So today, the data set I chose to use is the most up-to-date data set in asthma patients. It's the standard of care. Biotech drugs have been around for asthma patients for about 10, 12 years, something like that. And so this is a phase 3B. That means it's like a post-marketing commitment, sort of, to the FDA. A placebo-controlled, randomized, double-blind. The original purpose of the study was to evaluate efficacy and safety of an asthma drug. And these are moderate to severe asthma patients, and they're inadequately controlled. So they've tried all the inhalers, they've tried the LABAs and the SABAs and all the stuff that asthma patients typically take, and now it's time to look at potentially a biotech infusion. So these are very sick patients. For asthma, you don't take a biotech drug unless you're pretty sick. So this database has 850 patients, and half of them are on placebo and half of them are on the drug. Pretty standard phase 3 vanilla 1-year clinical trial. So as I said before, I think we're going to focus today on patient clustering for the most part. But if you're interested in variable clustering, SAS, I use SAS for clustering. I don't even know if Salford has tools for clustering. I'm not sure. So I use SAS. And then I feed those clusters into CART afterwards. So you can use proc variclust and SAS. It's a really nice procedure. Proc variclust, var, put all your variables in there. Every variable in your database, it'll create nice clusters for you. And you can set how many clusters you want. And so it helps you to take a first look at your data set as to what kinds of variables might be there. And then patient clustering, we use proc cluster. So it's more based on factor analysis, and it actually gives you, say, 7 or 10 or 15 clusters, but it doesn't tell you much about the patients. You don't really know what it was that made those clusters. And that's where CART can help you, because then you can predict a cluster, find out what the rules would be for those patients in a nice, clean way. So I kind of mentioned this already, SAS cluster for the patient case clustering. Just a couple slides on clustering, for patient clustering, for those of you who are interested. Clustering is neat. It starts with 1 cluster per patient. So if you have 850 patients, you start with 850, and then you start to cluster patients. Then you have, 849, and then you have 846, 6, and 5. So you shrink it down until you have 5 or 6 clusters. So you start off with every patient having its own cluster, and you just keep grouping patients until you have 1 cluster standing. And I used Ward's method, which is the default in SAS. And I'll put up a couple of slides for the math folks and someone like me who want to know more about that. But basically, every time you cluster, you're losing something. Kind of, it's like variables in a regression model where every time you drop a variable, your R squared goes down a little bit. So you're trying to create clusters in a way that minimizes the loss of information every time you cluster.